Lecture 4 notes. Last class, we talked about functions, like specifically we talk about linear functions. We said that f of x equals to, let's give an example, like 2x plus 3. So in high school, you may learn this. Instead of writing f of x, that's y. Y equals to 2x plus 3. So we know this is called a y-intercept, slope-intercept form, this one. Slope-intercept form, right? And this one, so 2 is the slope. Slope is the rate of change. It measures the rate of change of y and x. And this 3 is the y-intercept. Because the y-intercept has x value to be 0. So 0, 3 is y-intercept. That's why this equation gets named slope y-intercept form. So linear functions, so we know equations, some equations are functions, but not all equations are functions. But all functions are equations, right? We have equal sign here. So so today's material is related with this, right? And the graph of linear functions, we call this a linear function. The graph is the straight lines, right? Either goes this way, right? Or horizontally. So lines we know. So for if we have 1 point, the infinite many lines we can draw through this 1 point. But if we have 2 points, there's only 1 line we can draw, right? Go through 2 points. So any 2 points define a line. So the first question is we want to find the line representation, the slope. The slope. Maybe we do one step further, we find the line representation too. So given us 2 points, we can find the slope. And we can find the equation of the line passing those 2 points. So let me add that. Find the slope of the line, find the slope and the equation. Equation, it's like a name for the line, right? So it represents the line of the line passing those 2 points. So slope has a formula. Is y2 minus y1 from high school, if you remember, x2 minus x1. If we call this point x1, y1, so first point, we call this x2, y2, or vice versa. Or we can do this, we can do y1 minus y2, then has to be x1 minus x2. Okay, you see the consistency? If we start with y2 in the numerator, we have to start with x2 in the denominator. If we start with y1 in the numerator, we have to start x1 in the denominator. Okay, so let's follow this one. So y1, 5, minus y2, 3, divided by x1, 2, minus x2, negative 6. So 5 minus 3, that's 2. 2 minus negative 6 becomes 2 plus 6. That becomes 8. Simplify, we divide by 2 in the numerator, in the denominator. So we got a 1/4. So the slope is 1/4. Now let's write the representation. So we know the slope formula, right? Y equals to 2x plus 3. Y equals to, now we know the slope, 1/4, 1/4. X plus b, we just don't know b. But the xy represents any point on the line. So we have those 2 points to use. We may use this one, we may use this one. Doesn't matter which one we use. Right? So let's pick the first one to use. So the y value equals to 5, and the x value equals to 2. Then that's 5. So 1/4 times 2, that's half. Plus b. Okay. Then we move half to the other side to combine with the 5. So we'll have 5 minus a half equals to b. Well, 5, we can change 5 to be 10 over 2 minus a half, because we need a common denominator. 10 minus 1, that's 9. 9 over 2. So now we can write as y equals 1/4 x plus 9/2. So this is the name of the line passing through these 2 points. If I graph on here, so 2, 5, 2, 5, that's this point. Then -6, 3, -6, 3 to here. So the line will be this one cross those 2 points. And this equation is the expression, algebraic expression of this line. Okay, that's the first one. Let's see the second one. Second one, we want to find x-intercept, y-intercept, and a checkpoint to graph this equation. So for any equation, we can graph. Okay, we can calculate some points. So x-intercept means the points on x-axis. So all the points has y value to be 0. And y-intercept means all the points on y-axis, the x value is 0. So let's find x-intercept. X-intercept means y value is 0. So 3x minus 4 times y is 0, equals to 12. Well, -4 times 0 is 0. 3x minus 0 equals to 12. Well, minus 0 is minus nothing, so 3x equals to 12. So we divide by 3 on both sides, get x equals to 4. So we get 4, 0. So 4, 0 is x-intercept. Now let's check y-intercept. Y-intercept means x value is 0. So we have 3 times 0 minus 4y equals to 12. 3 times 0 is 0. 0 minus 4y equals to 12. Well, 0 is nothing, so just -4y equals to 12. Divide by -4 on both sides, so y equals to -3. So y-intercept is 0, -3. So let's graph those two. So 4, 0, the points here. 0, -3, the points here. So this is the y-intercept, this is the x-intercept. Well, we want to also graph a checkpoint. Checkpoint, we can let x be any value we want. So let's see if x equals to 2, right? We have 3 times 2 minus 4y equals to 12. 3 times 2 is 6. 6 minus 4y equals to 12. Right? So move 6 to the other side, it becomes -6. So -4y equals to 6. Divided by -4 on both sides, so y equals 6 divided by -4. Well, that's -3/2, -1.5. So get 2, -1.5. So x value is 2, y value is -1.5, is here. Now we can graph. So this is the graph of this equation. Now let's see 3. 3, we want to convert this equation into slope-intercept form, which means y equals to mx plus b. All right, so we need to find the m, we need to find the b. So we start with this. So first, we move 3/2x to the other side. So have 2y equals to, or positive on the left-hand side, move to the right-hand side, becomes negative. So -3/2x plus 6, because this 6 is positive. Then we multiply by its inverse. I multiply by half. Because half times 2 equals 1. So we get 1y equals to, first half times, so -3, 2x times half. What do we get? -3 times 1, -3. 2 times 2 in the denominator is 4. So negative 3/4 x. Then plus 6 times 1/2, that's 3. So usually 1y, we don't write this 1 here. We just write y. Y equals to negative 3/4x plus 3. So this is slope-intercept form. Negative 3/4 is the slope. Right? 0, 3 is a y-intercept. So graph it, we need only 2 points, right? So if x is 0, say y equals to 3. Right? If x equals to 0, y equals to 3, right? Because negative 3/4 times 0 is 0. Let x equals to 4. If x equals to 4, negative 3/4 times 4, 4 is 4/1. These two cancel. So we get y equals to negative 3 plus 3, which is 0. Right, so we get 2 points. We get 0, 3. We get 4, 0. X-intercept and y-intercept. So 0, 3 is here. 4, 0 is here. If we want, we can make one more point. We can calculate one more point. But I trust myself. I did the right calculation. So that's the line. Right. Oops. Okay. That's the graph. That's the graph of this equation. Now let's see 4. 4 is x equals to 2. So first let's find 2 on the x-axis. X equals to 2, right? This one. And at this point, x also equal to 2. And this point, x also equal to 2. And this point, so all these points on this vertical line have x value equals to 2. So x equals to 2 in two-dimensional world is a vertical line. So this is a line of x equals to 2. It's a vertical line. And B is a heading, so 2y equals to negative 6. So first, let's simplify. Let's divide by 2 on both sides. So we got a y equals to negative 3. So let's find y equals to negative 3. We see here, negative 3. And this point, the 1, negative 3, 2, negative 3, 3, negative 3, so on and so forth. Negative 2, negative 3, negative 3, negative 3, so on and so forth. So y equals to negative 3 is a horizontal line, right? So this is a line y equals to negative 3. So x equals the value of vertical lines. Y equals to a number of horizontal lines. So those two lines are special lines. And the horizontal line y equals to negative 3 is a function we call constant function. But the x equals to 2 is not a function because it fails vertical line test. Oh, hold on. Oops, so fast. Okay, let's see question 5. Question 5, so we use in life. So this graph shows the horizontal line, the x-axis shows time in hours. The vertical line shows infections for individuals, right? It's a wiggly graph, so the graph is wiggly. And what do we want to do? We want to find the average rate of change from 60 hours to 100 hours. So 60 hours here, 100 hours here. So the average rate of change means the slope of the line passing through these 2 points. Okay, that's the average rate of change. Because this is a wiggly line, right? So at each point, if we draw a line, the slope is different. So we can only talk about the average rate of change. So the average change, just a slope of this line crossing, connecting those 2 points. So if we call this x1, y1, we call this x2, y2. Right? So m equals to y x1 minus y2 divided by x1 minus x2, or the other way around. Y1 is 8,149.96. Y2 is 746.62. X1 is 100. X2 is 60. So the denominator is 100 minus 60. This is 40. The numerator, let's see, we have 8,149.96 minus 746.62. 6 minus 2, I have 4. 9 minus 6, I have 3. Decimal points, carry on. 9 minus 6, 3. 4 minus 4, 0. 1 minus 7, not enough. Borrow 1 from 8. 11 minus 7, get a 4. 8 minus 1, 7. So get a 707403.34. Then you can use the calculator, right, to divide those two numbers. Okay, so if I divide, first, I want to divide by 2, right? If I divide by 2, I get 20. And the numerator, if I divide by 2, I get 37. And then this is 0, then 1.1367. Okay. So I get, then this is 0, ask me to move this decimal place here. So I get 370.67 divided by 2. Then when I divide by 2, 37, it's 185.3, then 3 again, right? Then 5. That's it. So the average rate of change from 60 hours to 100 hours is this, 185.335. Let's see, 6. So 6, we want to write the equation point slope formula form. What is point slope form? Remember, slope is y2 minus y1 divided by x2 minus x1. If I multiply both sides with x2 minus x1, I can rewrite this as y2 minus y1 equals to m times x2 minus x1. And if I'm treating x2, y2 just as y, so I can write as y minus y1 equals to m times x minus x1. So this is called a slope point formula. Okay, so x1, y1 is a point. X comma y is a representative for any point on the line. So we're given m equals -3. We're given this point, let's call this x1, let's call this y1. Right? So we write as y minus y1, which is 1, equals to m -3 times x minus -4. Right? Because x1 is -4. Minus negative become plus. So we have y equals to, we'll move this one to the other side, becomes +1. Right? So we have -3 times x, -3x. -3 times 4, -12, +1. Simplify -12 and 1, so we get -11. So this is the graph. This is the equation of the line with the slope -3 and cross the point -4, 1. And this is a slope point formula, right? So slope is m equals -3 and y-intercept. The intercept here means y-intercept is 0, -11. And the graphic uses 2 points, right? One point is 0, -11, or we don't have -11 there. So maybe, let's see. So let x to be, so I want to make x to be negative, because negative times negative will be positive. Let's say x equals -4. Then we have y equals -3 times -4 minus 11. Negative 3 times negative 4, positive 12. Minus 11, that's just 1. So I get a 1 point. I get negative 4, comma 1, right? Negative 4, comma 1. That's this point. Now let's get the second point. Let's see x equals to negative 3. Then y equals to negative 3 times negative 3 minus 11. Negative times negative, positive. 9 minus 11, that's negative 2. So I get negative 3, comma, negative 2 points. So negative 3 is here, negative 2 is here. So that's my another point. Now I can graph. Right? If you don't trust yourself, you can do a checkpoint. You do third point. Oops. Do third point. All right. So usually we indicate it with an arrow. Just keeps going. So that's the graph of y equals negative 3x minus 11. Now let's see 7. I think 7 is the last question. Yes. So 7a, we need to find the equation of the line passing the origin and the parallel to this one. So parallel lines have the same slope. So this one have a slope of 4. So m equals 4. That means the line I'm looking for also have slope of 4. So I can write it as y equals to 4x plus b. Okay, I don't know b. Now, I'm given this point on the line. So that means that x comma y can be 0, 0. That means y is 0, x is 0, plus b. Well, 4 times 0 is 0. So that means b has to be 0. So my equation is y equals to 4x. That's it. So any line, if passing through the origin, we just have this form, no b, because b is 0. Okay, so we have this point, 0, comma 0. Then if x equals 1, y equals 4. Right? If x equals negative 1, y equals to negative 4. So we can graph. It's very difficult to. Okay. Yeah, that's the graph. That's the graph of equation y equals to 4x. Okay, so what did we use? We use the slope of the parallel lines. So for B, it's perpendicular. So two lines perpendicular means they form 90 degrees. So if this slope has M1 as M1, if this one has slope M2, M1 times M2 equals to negative 1. Or M1 equals to negative 1 over M2. Similarly, M2 equals to 1, negative 1 over M1. So those for two lines have been perpendicular to each other. So multiply the slopes, we get negative 1. Or one slope is the opposite, inverse of the other. So we need to write down the equation passing this point and perpendicular to this. But we won't be able to tell the slope of this one, right? Unless we solve for y, unless we put in y slope intercept formula. So first, let's move x to the other side. So we get negative 3y. Positive x on the left, move to the right, becomes negative. Plus 1, right? Because this 1 is positive. Then divided by negative 3 on both sides. So y equals negative x divided by negative 3 plus 1 divided by negative 3. Negative divided by negative, positive. And x, so we get x over 3 minus 1 over 3. Now we won't be able to tell the slope, right? Unless we write it as 1/3 of x minus 1/3. Because this 3 is in the denominator. So it's not 3 actually, it's 1 over 3. So this is the equation of this line. Now we're able to tell the slope. So slope M1 equals to 1/3. And M2, because the two lines perpendicular, M2 is the opposite 1 over m1, or opposite negative 1 over 1 over 3, which is just -3. All right, so now we have slope, -3. And we're given this point, we use slope point formula. So y minus -1 equals to -3 times x minus 6. Y minus -1 is y plus 1. -3 times x, -3x, -3 times -6, positive 18. Now move this one to the other side, becomes negative. So y equals -3x plus 17. Okay, so that's the equation. So this is the equation of the line passing 6, point -1 and perpendicular to this line.